Ancient Romans named the shimmering red body in the firmament after their god of war. No other planet in our solar system seems more likely to become a second home for humans in the not-too-distant future, especially since it offers a surface area similar to Earth's land masses. Remember, oceans cover 70% of our planet. Mars takes 24 hours and 37 minutes for one revolution around its axis, so a Martian day is only slightly longer than ours on Earth. However, for an orbit around the Sun, it needs 687 days. Mars also has seasons, an atmosphere, water, ice, raw materials, and gravity. But Mars is significantly smaller than Earth. Therefore, its gravity is only 1/3 of Earth's gravity. As a result, Mars is home to Olympus Mons, the tallest volcano in the solar system. The red planet's atmosphere consists mainly of carbon dioxide and has a thin atmosphere with a pressure of 1% of Earth's. The thin atmosphere is also the reason why landing on it is so difficult. Since every non-spacefaring civilization is threatened with extinction or is known to become extinct, Mars seems the perfect place for Earthlings to visit. But because of the great distance between Earth and Mars, any human settlement would have to be as self-sufficient as possible. The first person who wrote about a Mars base was Gustavus W. Pope in his science fiction story A Journey to Mars, 1894. The first non-fictional book about a Mars base was written by the German rocket scientist Hermann Oberth in his 1923 book The Rocket into Interplanetary Space. Oberth outlined a plan for a Mars base built in a crater near the equator. He believed that a Mars base would be essential for the exploration of the red planet and the eventual colonization of the solar system. Also in 1948-49, Wernher von Braun wrote about a manned mission to Mars in his book The Mars Project. We already made a short video about it and his prediction of the future Mars leader titled Elon. But there are a whole series of challenges for a Mars base. Surface radiation and the lack of a global magnetic field. Unlike Earth, Mars does not have a global magnetic field to protect living beings on its surface against cosmic rays or solar flares, which is a real problem. But the InSight probe discovered that Mars once had a global magnetic field that left behind ghosts, traces of this ancient field frozen in the crustal rocks. InSight's magnetometer found that ancient rocks between 61 meters and several kilometers below ground are strongly magnetized. The crustal magnetization remnants are 10 times stronger than expected based on measurements by orbiting spacecraft. Furthermore, there is a high energy and harmful UVC radiation on Mars. Therefore, there's only 3 possibilities. First, the outer skin of the building you'd be in would have to be shielded. And at times of particularly strong solar activity, there could also be a separate shelter where Mars astronauts could retreat. This retreat could also be surrounded by custom and drinking water and have specially designed protective walls. Second, the first human habitation on Mars could be built underground, for example in a cave. Third, strong artificial magnetic fields could be installed to protect the Martian base against radiation. To enable long-term life on the surface of the planet, it would also make sense to build an artificial global magnetic field that would encompass the entire planet. Sandstorms. A specific Martian problem is the sandstorms on the planet, as they have a tremendous spread and intensity, as this image from the European Mars Express probe shows. Power supply. Mars receives abundant sunlight, but its thin atmosphere reduces the efficiency of solar panels. On the one hand, solar panels on Mars produce less electricity than they would on Earth. And on the other hand, the thin Martian atmosphere contains dust particles and other aerosols that scatter sunlight. This means that less sunlight reaches the solar panels directly, and more sunlight is scattered in all directions. Therefore, the energy yield by means of solar cells is much lower. And because of the risk of solar storms, it's likely to have power outages. That's why we have to rely on nuclear energy. NASA is already planning to use it and has a miniature power plant under development, the Killer Power Project. The prototype, which runs on uranium-235 as nuclear fuel, has already been presented to the public Up to 10 kilowatts of electricity can be produced over a longer period of up to 10 years. Life support system. The life support system is a particular technical challenge since it must first allow human life on the planet, and it will also require a low-maintenance continuous operation since it would be impossible to shut it down. Agriculture on Mars. You have to get the food directly on site for the astronauts. That's why agriculture would be nice, but there's a serious problem with the Martian soil. As the Mars probe Phoenix found out in 2008, there is a high concentration of perchlorates in the Martian soil, which inhibit the absorption of iodine and thus have a negative effect on the metabolism of the human thyroid gland. So food grown on Martian soil is not really suitable for human consumption. Therefore, vertical farming with an artificial growing medium is a possibility, since it's easy to build up in height due to the low gravity, if a solution to the radiation problem is found. Low temperatures. Mars is permanently very cold, colder than it gets on Earth. Temperatures as low as minus 140 degrees Celsius have already been measured, so this would be a challenge for the equipment. Building and foundation techniques. Initially, we would have a modular Mars base with airlocks, but over time, building domed settlements would make sense. How geologically active the planet is was explored by the InSight probe, which lost contact with Earth in December 2022 after 4 years on Mars. The results? The planet has a surprisingly thick liquid core with a radius of 1,800 kilometers. The Martian crust is 25 to 40 kilometers, much thinner than previously thought. Mars is much more seismically active than previously thought. The probe recorded over 1,300 seismic events. The last one, in May 2022, had an estimated magnitude of 5, with vibrations reverberating through the planet for at least 6 hours. In addition, InSight's onboard seismometer detected a magnitude 4 Marsquake in 2021 that scientists later determined to be caused by a meteoroid strike. This was one of the biggest meteor impacts on Mars since NASA began exploring the cosmos. For a Mars base, this means that it not only has to be built Marsquake-proof, but that a solution is also needed for meteoroid showers. A further challenge here would undoubtedly be to manufacture concrete using Martian soil, because it is as important for the foundations of the Martian colony as it is for the rocket launches and landing sites. Scientists at Northwestern University have tackled this problem and have mixed a Martian concrete that even hardens without water and whose main ingredient is sulfur. On-site production. It would have to be advantageous to have an automatic fuel refinery that uses a Sabatier process to convert hydrogen, H2, and the abundant carbon dioxide, CO2, in the Martian atmosphere to methane, CH4, and oxygen, O2, which could be used as rocket fuel, and in a further step to produce water, H2O, using a Bosch reaction. Additionally, we'd need a 3D printer to make tools and spare parts. The less we depend on supplies from Earth, the more economical a settlement on Mars would be. Unlike the early plans of space agencies, which mainly consisted of flying to Mars to plant a flag, Elon Musk wants to permanently colonize Mars before the end of this decade. If that ambitious timetable does not work out, it will not be long before humans are living on a planet other than Earth. Thank you for your attention. If you like this video, check out our other videos about the Red Planet.